In just 5 lines of code, I got a simple RAG application with LlamaIndex working. Today, I'm excited to go over with you a flexible data framework that allows connecting custom data sources to LLMs and so much more. By the end of this video, you will understand and be able to create anything with LlamaIndex. We have a lot to go over and code. Let's get started. Well, what is LlamaIndex? Like I mentioned, LlamaIndex is a simple, flexible data framework for connecting custom data sources to large language models. It basically serves as an interface that manages the interactions with the LLMs and at a high level creates the indices or indexes from our input data, which we can then later ask questions about. RAG. LlamaIndex includes getting data from different data sources, embeddings, LLMs, vectors as input, and it can then output or generate Q&A, structured extraction, chatbots, and AI agents. LlamaIndex can load data from over 160 sources, integrate with more than 40 vector stores, execute advanced RAG to AI agents, like I mentioned, and it also has ways to evaluate performance with different integrated partners, such as Agent Ops or Arise. It has data connectors to ingest data from different sources with APIs, PDFs, documents, SQL, and others. It also provides different ways to structure your data like indices or graphs so that the data can be easily used with LLMs. It also has advanced retrieval query interface over your data. It has easy integrations with other application frameworks such as LangChain, ChatGPT, Flask, etc. And like I mentioned, it has a way to observe what's happening under the hood. And like I said in the beginning, the high-level API allows beginners, like I was, to use LlamaIndex to ingest and query data with just 5 lines of code. Now, while I obviously can't go over everything in this tutorial because this is a beginner tutorial for LlamaIndex, we do have 7 different projects that we're going to code together, starting from a basic, simple RAG to a chatbot, to understanding the full RAG pipeline with LlamaIndex, and we'll create our own AI agent and something relatively new to LlamaIndex, the Llamaparser, which is a much more advanced parsing technique that they offer. This will be in my GitHub, so you're more than welcome to follow along or start from scratch like I'm about to with the code. Let's start coding. All right, now to start the project, we're gonna get right into this. I need a couple things that I need you to do. So the first thing we're gonna do is create a .env file, and this is gonna help us make it easier when we have our API keys to use throughout these projects. So the first one is your OpenAI API key. So just put this here, and then the Phoenix API key, you won't know what this is yet. So when we get to that project, which is a little bit later on, I'll show you how to get this free API key. The next thing is I have a data folder and a PDF folder, right? This data folder I will have in the description. This is going to take a request that you just put in the terminal. It's going to go ahead and download it and put it into this directory here, which we'll also use in a later project. And then what we're going to use in this first project is the AutoGen Studio PDF. So I'll have this in the description. It's also in my GitHub. So you just want to download this, create a PDF folder, and then basically drag and drop this into the project. And now let's go ahead and create our virtual environment. So I'm going to type in python-m venv, then .venv to create the virtual environment. And when this is successful, you'll see in the top left the .venv. Now we need to go ahead and activate it. So I'm going to type in source .venv/bin/activate. And now when we go ahead and perform our installations, it's just going to be for this virtual environment for this project. It's not going to be global because it can mess up with version libraries. Now there are a few things to install. So we're going to type in pip install LlamaIndex, LlamaIndex core, and also python-env. Okay, that might take a few minutes, but now we are good to go. So let's go ahead and create our first file. So in your project pane, new file, I'm just going to name this o1-simple-rag.py. Now that we have the file, let's begin with our imports. So from .env import load.env, then we need from LlamaIndex.core, we need to import 2 things. We need to import the vector store index, and we also need the simple directory reader. And then we need from llama_index.llms.openai import openai. Now there's 2 ways we can do this. You could actually just set the, you can import OS, set the environment variable, and hard code your project key in here. But I'm going to do it this way because I'm going to use this for the rest of the project. And it's good practice to store all of your keys into an environment variable. So then the next thing we need to do is actually load our environment variable keys. And then let's go ahead and instantiate the OpenAI object. So we can actually give it the model here as well. So we can say GPT 4.0 or even 4.0 mini, because that is super cheap. And now we need a way to get the documents. So we can say documents is equal to the simple directory reader. And now we want to get it from the PDF directory over here, right? Simple PDF directory is the most basic data ingestion way to, for RAG. It's because it takes any directory and gets all kinds of files from there, including docx, CSV, PDF, and more. So we're going to say PDF slash and then dot load underscore data. Now we need to create the vector index, which is basically a data structure that stores and manages all of our data from the documents as vectors that allows us to perform searches and queries on them. I'll go over this more when we have our advanced RAG pipeline. So we'll say index is equal to vector store index dot from documents, and then we need to give it the documents. And then we need to create what's called a query engine. So query engine is equal to index dot as query engine. And this basically allows us to perform Q&A on all of these documents. Then we're going to say response is equal to query underscore engine dot query. And then we can just ask a question. So let's say, what are the design goals? And please give details about them. And then let's go ahead and print this out. So print response. Okay, now to run this, you can also just right click the file and go to run Python file in terminal. And now it'll bring it up and it's going to run it for us. And great. So went ahead and said the design goals of AutoGen Studio. This is from the PDF. And I do know for a fact that there are 3 topics that it should discuss: developer tooling and reusable templates. And it just, gives you some details about that inside of the PDF. And that's great. We just finished your first simple RAG pipeline, and it was not many lines of code at all. Okay, so let's go ahead and create another file. We're going to name it o2-chat engine.py. And as you noticed, you can actually copy and paste the imports from the last one, which is what I'm going to actually go ahead and do. So I'm going to copy these, paste them here, because they're going to be the same for this one. And a lot of these imports are going to be same for these projects. And I'm going to show you another way to import the LLM specifically into this chat engine. So let's go ahead and create a variable for OpenAI. We're going to say the model is equal to GPT 4.0 mini again. Okay, now this time I'm going to use the data from the paulgraham.essay.txt, which is in the data Paul Graham folder or directory. So we're going to say data is equal to the simple directory reader again. And we can just say /data /Paul underscore Graham / and then .load underscore data. Okay, now that we have the data, we need to create the vector store index again. So we're going to say index is equal to vector store index dot from documents, and then give it the data. And now let's go ahead and create our chat engine, which will be a little different. We did the query engine last time. So we'll say chat underscore engine is equal to index dot as chat engine. And then chat underscore mode will be best, which I'll go over a few of the different chat modes in a second. And then we'll say LLM is equal to the LLM. And then this time we'll say verbose is equal to true. And here are all of the different chat modes. We're going to use, again, best. This is actually the default one, but there are others here. A lot of these just deal with the different system prompts. Simple, I think this just directly talks to the LLM, but we're going to use best, but you can experiment with these other ones. And then we're going to say response is equal to chat underscore engine dot chat. And then this time I want to say, what are the first programs Paul Graham, if I can pronounce or say that or spell that right, tried writing? And then let's go ahead and do a print response. Now, again, I'm just going to right click on chat engine and run this in my Python terminal. I'm going to bring this up for us so we can see it. Okay, so this is a little different, right? The first thing it did was added a user message to the memory. And this is the question that we asked it. And it then went to call a function, right? But the calling function just used the query engine tool. Well, the reason is because we needed to talk to the documents, right? So it used a query engine tool to get the relevant information to answer this question. And then it got the output here. And then that is what we see. And you might be thinking, well, this doesn't really look like a chatbot, right? This is kind of more like a Q&A because it actually even used a query engine tool to get the relevant data from the text. And well, I can definitely see your point. So let's go ahead and turn this into a chatbot. What I'm going to do is to separate this out is I'm going to create another file. So it's a o3-chatbot.py. And I'm going to go ahead and copy all of this up to the chat engine. So let's paste this in here. And then now what we're going to do is have a loop. We're going to say while true, we're going to say text underscore input is equal to the input. And then we'll say user. And then we say if text underscore input is equal to exit, then break. Otherwise, the response is going to be equal to chat underscore engine dot chat. And then this is going to be the text input. And then we can say print, and then we want to format it. So we say agent, not angel, agent, and then give it the response. Okay, let's go ahead and save this. And now let me bring the terminal back up that we had. Now let's go ahead and run this. So run this here. And now it's saying this is me as the user. Now I'm going to say, who is Paul Graham? I'm showing this because now it's going to make a little more sense of why the chat engine is a little bit different. And now that we're creating a chatbot. Well, the chat engine has more context awareness, which means that over a series of exchanges, it can maintain the context of things that we're asking it, in which a query engine is really just more of like single shot question answering. And so the more questions we ask it, it can just implicitly reference the memory because it's always like here, it's adding user message to memory, right? So it can take from past memories and implicitly give us answers based on those. So the agent gave us an answer, and one of them is that he is a co-founder of Y Combinator. So now I can say, when did he help found Y or YC? So now it added this message again. It did have to do another query engine tool with different arguments. And then, see, it actually kind of reworded it. It said, when did Paul Graham help found Y Combinator? And then the output is now Paul Graham helped found Y Combinator in 2005. And now, as you can see, this is acting more like a chatbot. Okay, I just want to say you've done great so far. Now, the next project is a more advanced RAG pipeline. And so we're going to go in each individual step of the RAG and create that ourselves. So this is going to be more code. But first, I do want to explain all the steps with LlamaIndex. Okay, well, there are 4 steps to this pipeline. We have loading, we have the indexing, and then we have storing and then querying. So before LLM can even do anything with our data, we need to give it data, right, and load it. So the easiest way to do this, which is the way we've been doing it, is with the simple directory reader. And this creates the documents out of every file in a given directory and then chunks them together. And it can also read a variety of formats like I have mentioned. But there are also so many other ways to load data. And one of those ways is with Llama Hub, right? I'll have this link in the description, but has all these data loaders that you can just use and they're ready to go, such as a simple web page reader and an RSS reader. The next step is indexing. And you've already coded this a couple of times with the vector store index, but an index is a data structure composed of document objects designed to enable querying by the LLM. And the vector store index is by far the most frequent type that you'll use. So it takes those documents that we're loading, it splits them up into what they call nodes. You can also think of them as chunks of text, and then it creates the vector embeddings of those texts. Well, the next step then is storing all this. So now that we have the data loaded and it's indexed, we'll want to store it somewhere because every time you index the data, which by default is in memory, it takes time and it costs money. And we don't want to do that. This is where vector stores come into place. The API calls to create the embeddings in a vector store index can be expensive, it depends on the documents and how much you have, and it costs money. So we'll want to store them to avoid constantly re-indexing things every time we run our program. Now, LlamaIndex supports many of these. We're actually going to use ChromaDB for this next example. And the last step is querying, right? Now that we've loaded our data, we've built an index, now we've stored those indexes or indices for later, now we're ready to do the best thing or the thing that we want to do for our LLM application, and that's querying from that data. The simplest way to do this is to create a query engine, give it some query, and then just get the response back. But we can actually go way more in depth with that. And that is just a simple example, but it's not good for all cases, right? That's just a basic case example. We can actually fine tune that, which we're going to do in this example. And it has 3 steps for querying. We have a retrieval, a post-processing, and a response synthesis. The retrieval is where we can specify the most relevant documents based on the query. The post processing is once we have those, we can actually filter them, we can re-rank them, or do other things with those nodes. And then the response synthesis is when your query, your most relevant data, and your prompt are combined and then sent to the LLM to give us a response back. Now, I know that was a lot, so rewatch that if that didn't make sense. But now we're going to go ahead and code this more advanced RAG pipeline and code all of the parts ourselves. All right, let's go ahead and create another file. I created one called 04-ragpipeline.py. And as you see, I have a couple things here already. And this is just to help us understand what's happening step by step, because this is going to be more code. So I have these simple imports that we already used. The first thing is we need to load our data. So we're going to say documents is equal to simple directory reader. And we're going to give it the ./data/Paul Graham/ and then .load data. Okay, we've just done the first step, right? The first part is actually getting the data from somewhere, ingesting the data. Now we need to create an index. Now, before we get into this, let's go ahead and install a couple things that we need. We need to install ChromaDB and then also LlamaIndex vector stores Chroma, because we're going to use the specific vector store and it's going to be Chroma. So go ahead and run this and let it install everything. Okay, great. Now we can go ahead and import ChromaDB. We're going to import the vector store index, the Chroma vector store, and then storage context. Okay, and this will make sense here in a few minutes. And yes, you can go ahead and put these at the top of the file, which I would do after this, but this is just step by step so you can see what's going on. So now we need to initialize the ChromaDB. So we're going to say db is equal to ChromaDB dot persistent client. And then we say the path, we just want to store it in kind of the same path, ChromaDB. This is going to initialize the ChromaDB client to save the data. Now we need to create a collection for this. So we're going to say Chroma underscore collection is equal to the Chroma database dot get or create collection. And then we'll just call this quick start. And now we need to assign Chroma as the vector store to the context, right? So now we're going to say vector store is equal to Chroma vector store. Then we'll say the Chroma collection is equal to Chroma collection. And then we can say storage context is equal to storage context dot from defaults. The vector store is equal to vector store. Okay, so just to recap here, we created a Chroma database, right? This is going to be persisted once we run this into our project. We have to just create a collection for that database because you can have multiple. And then we created a vector store, and this is actually a Chroma vector store based on the Chroma collection. And the storage context is a container for storing the nodes, indices, and vectors. And we'll see that in a minute. And this is basically just a way to persist it and use it later. But now the next thing is we need to create a vector store index based off of the Chroma database. So how we're going to do that is we're going to say index is equal to vector store index. This is what we've done before, right? Dot from documents. Now we need to give it the documents, right? So we're going to say documents. And then we need to give it the storage context. So storage context is now equal to the storage context we just created. Now before, we never gave it the storage context variable, right? Or this parameter. And that's because by default, if you don't, the defaults are just none for everything. What the vector store is, none of it. It's all none. But now that we gave it a storage context, we want to specifically use Chroma database. We want to use this Chroma collection. We want to use that specific vector store. And we want to persist into the .chromadb file path. Okay, so now the last step is to create the query engine, right? We loaded the data. We've created our index. We created a vector store indexed from ChromaDB, and now we're at the querying part, now that all that's ready. So there were 3 steps to that, so we're going to go over all 3 of those steps. Now we do need some more imports for this step, and again, at the end, we can put all these at the top. Now the first of the 3 steps is the retrieving part. So we're going to say retriever is equal to vector index retriever. We say index is equal to index, and then we say similarity top k is equal to 10. Okay, now the next step of the 3 is the response synthesis, right? So we're going to configure that. We're just going to simply say response synthesizer, if I can spell this. is equal to get response synthesizer. Now, the main idea of this response synthesizer is to get the best response from the LLM based on other things, like we're about to do the post processing and the vector index retriever that using the similarity top K of 10 searches. Next, we need the query engine. And this is where we're going to do the post processing. We're going to use the retriever query engine. We're going to say retriever is equal to retriever, and then the response synthesizer is equal to response synthesizer. I have to say that slow. And then we say node post processors is equal to, and then in brackets, because you can have more than one, we're going to say similarity post processor, and then similarity cutoff is equal to 0.5. So whenever we get the similarity search, there is like a score for it, right? So we don't want any score below 0.5. Anything above that is good. And so this whole query engine is going to take the retriever, the response synthesizer, and this node post processor, and then we're going to get a response from the LLM based off of these. Now, finally, we can get a response from this. So we can just say simply response is equal to the query engine dot query. What is the meaning of life? And then we can say print, just so we can see where it's at, and then print response. Okay, that was a lot, but let's see it in action. So I'm going to move the terminal up here so you can see it. I'm going to clear this and then right click and run Python in terminal. All right, so we did all of that just to get one sentence. I know that's a lot. And there's one more thing that I want to show you is, well, first off, you can see up here, there is a ChromaDB now. It exists. So what you could do is you could say, if the ChromaDB exists, we just want to load that again. We don't want to redo all this, right? Because as of right now, it's going to recreate it every time. But we should be able to load this directly once it's created. So here where we create the vector store index, we actually don't want to create this again, right? We want to load this. So we want to say index is equal to vector store index dot from vector store. Then we want to give the vector store is equal to, well, just vector store. And then the storage context is equal to storage context. Now we can just load what we've already created. So now let's try to run this again. And well, we still get the same answer, but again, we didn't create it, right? We didn't have to pass in the documents, right? We did not pass in any documents because they already exist in ChromaDB. Okay, so I know that was a little bit of coding, but what this showed you is that you have more control of how you want your RAG pipeline to work. And that's essentially what you need to really kind of know, because RAG is different for different use cases. Now, I still have 3 more smaller projects that I want to go over with you. Now, the next one is observability, and that just basically means what's happening under the hood, or where things basically maybe aren't working. Now, for the next project, it's called observability. And basically, whenever we run something with LLM, we want to see maybe how much it costs or what's actually happening under the hood. So let's get to that. Now, before we get started, we do need to get an API key for Phoenix, which is what's going to help us with the observability. And to do that, you need to go to llamatrace.com/login. Go ahead and just create an account. It's free. Now, as you can see, I've already kind of used it, but before we get there, we need to get our API key. So on the left-hand side here, just kind of hover over it, go down to keys, and then just copy this key here. Now let's go ahead and create a new file. We're going to say 05-observe.py. Okay, so I just went ahead and pasted some of the stuff because it is a little bit repetitive, and I can just actually go over this maybe while you're typing this out, or you can copy this from my GitHub. But after the imports here, we have a couple different ones. We need to set this Phoenix API key variable, and it gets the Phoenix API key from our .env file. And when you come back to LlamaTrace, you just click this copy button and it gets your API key, and go ahead and paste it in there. So go back to your .env file and put it there. And then we need this line, which we get from here. So you just copy that, put that here, and then I just had to add this F for formatting and then give it the Phoenix API key here. And then it doesn't really set it this way, but you set the global handler to the integration arise Phoenix, and then this is the endpoint. Okay, and once you have this, we are actually ready to go ahead and start with the RAG. So we can say documents is equal to simple directory reader. Let's go ahead and use the PDF again. So PDF slash, and then dot load data. Now for this one, I'm going to go ahead and have an if else statement. So let's see, let's do if os dot path dot exists. Then we'll say storage. Then we'll say print loading index from storage. And then we say storage underscore context is equal to storage context dot from defaults persist data equals storage. All right, that's like the directory. And then we say index is equal to load underscore index from storage, the storage context. Else print if we haven't done this yet, we need to create the new index. And then we can say index is equal to vector store index dot from documents, and then give it the documents. And then we can say index dot storage context dot persist, and we want the persist directory to be storage. And now finally, we need the query engine again, right? This is how we're going to perform our Q&A on it. Then index dot as query engine. And then finally, let's get a response. So response is equal to query engine dot query. What is AutoGen Studio? Please give as many details as possible. All right, and then we can go ahead and print our response. Some of this we've kind of already done. This code right here is just, we don't have to worry about every time, like, oh, let's load it this time after we persisted it. So you can do probably maybe something else with this, but I just chose to do a simple if else statement. Now we're gonna go ahead and save this file. Then let's go ahead and run it. So again, we don't have a storage path over here just yet. So I'm going to right click on this, run the file, and it looks like we ran into an issue, right? This happens. I think actually what I've been doing is I've been spelling Phoenix wrong. This is supposed to be OE. And then I believe I'm going to check my .env file to make sure this is spelled right, because maybe I didn't spell this right. Yeah, so that's what it was. I did not spell Phoenix right. So let's go ahead and try this again. Oh, and look at that. There is one more. And I totally forgot to tell you to install this package. We need this. So go ahead and clear this and go ahead and pip install LlamaIndex callbacks arise Phoenix. This is the actual integration that we need so that we can go back to LlamaTrace and see what our LLM is doing under the hood. It's okay to make mistakes. Just make sure you understand what they are and try to do them again. Like me, I've done this way too many times already. Okay, awesome. So as you can see here, it created the new index. So it didn't exist, right? This path didn't exist, but it went ahead and created the storage here for us. And this is the default storage, right? So it created the directory and then stored everything we need to know. And if you really want to get into this, right, the storage, you can go to default vector store. Look, these are all the embeddings, right? These are actual vectors stored into the database, but it just uses JSON by default. Okay, so when it did that, and then we had the query, and it basically goes into detail about what AutoGen Studio is. Now, this actually took like a minute, at least maybe for my hardware, but this took over a minute, right? And that's what I was saying before. Now, if I rerun this again, this should not take that long at all because it no longer has to see it's loading index from storage, and then it's just going to answer the question based off that already. And that took maybe 5 to 10 seconds, whereas the first time it took over a minute because I had to create the index. Okay, now that it's done, let's go back to LlamaTrace. Okay, now that we're back in LlamaTrace, as you can see, it gives some information here on the basic dashboard. So we had the start time, the latency, the amount of tokens everything took, and the status. So let's take a look at this top one, and it goes into detail about everything. So here is the base retriever, right? We didn't specify a retriever query engine like we did in the RAG pipeline. So it uses a base one. Uses a vector index retriever here. The basic OpenAI embedding. So it has to get the embeddings based off of this query. And here's the base synthesizer, right? But in the last project, we gave it one. We gave it a specific synthesizer, but here it's just using the base one. It's using a token splitter. And you can come back to all the way down here to the OpenAI chat, right? So here is the system prompt. Here is the user. So this is the context below for what we're going to be using for the question. And then the assistant, if we come all the way down, the assistant gave this output, which is what we actually see in our terminal. But you can come in here and kind of see what's actually happening in the background. And this is just one way to get metrics, right? I mentioned agent ops. That is another one, but with the newest version of LlamaIndex, it isn't quite compatible just yet. But by the time you're viewing this, it may be. Okay, great. Observing what your LLM is doing is wonderful. You should always know what it's doing, and something like this is a great way to do that. Now, for the next thing, in my channel, I talk about AI agents a lot. So we're going to create a basic agent with tools in the next project. Let's do that now. So let's go and create another file, and we're going to call this 06-basic agent.py. Now, I'm not going to use the tracing again because I already created a project that does it. But if I were you, I would, keep just testing the code and doing it for yourself for every project that we create now. So now we have a few imports. So we're going to say import os from .env, import load.env, from llamaindex.core.agent, import react agent, from llama index.llms.openai, import openai, from llamaindex.core.tools, import function tool. Now we can go ahead and say load.env, and we're good to go. Now we're first going to say LLM is equal to openai, specify the model. So for this one, I am going to say GPT 4o because I know that it does well with function calling. And now what we're going to do is create some calculation functions because I want this agent, given some math, some math equation, use the given functions to solve it. So I'm going to create the first one, and then I want you to create 3 more. So the first one is going to be, just going to create a basic Python function. So define add. We want the first parameter to be a float, the second parameter to also be a float, and then we want to return a float. And then you also want to give Python documentation to each of these functions so the LLM can have an understanding of which function to choose. This is really going to help it out. So make sure you have these doc strings in your functions. So we're going to say add 2 numbers and return the sum. Basically, we're just going to return A plus B. And that's it. Now, I want you to go ahead and try this for the subtraction, multiplication, and division. So go ahead and pause this and then replay this whenever you're done. Okay, so you should have something like this. So it's essentially the same thing: subtract, multiply, and divide. Just make sure you have the same parameters and everything. Okay, these are simple functions. Now, the problem is when we give this to the agent, these are just regular Python functions, but these need to be like kind of transformed into a function that it can actually understand. So in order to do that, let's take the addition one first. We're going to say the add tool is equal to function tool dot from defaults, and then we're just going to say fn for function is equal to add. And we're going to do this for all of them, and this is going to wrap the actual Python function into a way the LLM can understand it. So let's go ahead and copy this. We can say subtool, multiply tool, and then division tool. And then instead here, I can just copy paste subtract, multiply for the actual name of the Python function. Okay, and great. Now we are going to be able to add all these to our agent. So let's go ahead and create the agent now. Now we say agent is equal to, the type of agent we are going to use this time is the React agent. And basically this has a different system prompt from other agents. And we'll see this whenever I set the verbose to true, you'll see this in the response. So we're going to say React agent dot from tools. Okay, so now we need to give it all of these tools, and it's going to be specified as an array, or I'm sorry, list. So we're going to have the add tool, the subtraction tool, the multiply tool, and then the division tool. We're going to specify the LLM is equal to the OpenAI LLM we created. And like I said, I want to say verbose is equal to true. Then the response is going to be agent.chat. And we can just say, let's just give it some equation, right? How about let's do something kind of simple, like 20 plus 2 times 4 divided by, how about we do 6 minus 3 or 2? Okay, I put in 2. Use a tool to calculate every step. Right, and then let's print this out. So print response. So I'm going to bring the terminal up here, and let's just go ahead and run this so we can see what the output is doing. Okay, so it ended up giving a result of 22. I am assuming that's correct. I don't actually know, but let's just see what's happening. So we have the React agent. So it has a thought, an action input, and then the observation from that. Okay. So the first thing is the thought is, saying the current language is English. It needs to break this down into smaller steps and use the appropriate tools. So the first thing is going to do, okay, so here's the equation. First thing to do is going to say multiply 2 times 4. Okay, so it finds this first. So the action input is A is set to 2 and B is set to 4. This is the multiply function. So then it returns 8. And then the next thought is saying, okay, that's 8. Next, I'm going to do the subtraction, 6 minus 2. And I assume it's using PEMDAS, so it's doing the parentheses first. So it's doing the subtraction function. 6 is A, and then B is set to 2. The result of that is 4. So it says 6 minus 2 is 4. Then it's going to divide the result of the multiplication by the result of the subtraction. So it's going to be, we got 8 here, and then we got 4 there. So that is going to be 2. So the result is 2. And then it's going to add 20 to that result is 2. It's going to use the add function. So 20 plus 2, and that is how it got 22.0. And it showed us the input all the way. Okay, great. We just created a basic AI agent given 4 different tools it was able to solve the math equation. Now, the next thing I want to show you is what's called Llamaparse. There's actually also something called Llama Cloud. However, you have to join a waitlist, and I joined it. I just haven't been accepted yet. And that is something completely different, which I'll go into another video. Maybe once I get accepted, I can't really show you anything without it. But for Llamaparse, what they've done at LlamaIndex is create a better way and a more advanced way to parse data from a PDF, for example. So let's look at what Llamaparse is and how it's different. Okay, so let's go over what Llamaparse is. And by proxy, we're also going to be kind of talking about Llama Cloud. But like I said, I am still on the wait list for that. So I personally can't show you what it is. But what they're basically saying here is the whole thing about RAG is actually not as easy as it seems, right? Like we have code, right? And it kind of gave us, it performed well because I kind of know what the answers are already, especially for AutoGen Studio. So it did it, but also the PDF wasn't that long and it wasn't that complex, right? What if we get into PDFs that have tables, they have different like kind of pictures that have data that you need to extract from? That's where it can kind of become a problem, right? So they're talking about the results aren't always accurate enough. The PDFs can be a problem, right? So if you have, like I said, if you have complex documentation, how can it actually retrieve the data you want? And so this is where they're talking about Llamaparse, right? They're saying this is a state-of-the-art parser designed to specifically unlock RAG with complex PDFs that have embedded tables and charts. And we're going to create a sample coding project after I go over this, right? So the one thing about LlamaIndex, and I have heard, this is, I don't actually have a lot of like data to show you myself, but what I have heard is that it is really good. LlamaIndex does really well at parsing data. So if we look at this, we have this image that they had here, right? So the left-hand side is, these are the same documents, right? But the left-hand side is using LlamaParse, and on the right side is using another popular library called PyPDF, which many of you may have used already. And to be honest with you, a lot of these things that parse PDFs, so we perform RAG on them, have used PyPDF, especially LangChain. But what they're saying here is PyPDF on the right, when it tried to do this, all the things in red, this is what it's failed at, right? So all the ones in red is which it did not properly retrieve. But on the left with Llamaparse, there's only one thing from the table that didn't read properly. Well, yes, it still wasn't 100%. It's still better. It's still much better than what PyPDF has had. Now, of course, this is using their data, but this is a really complex page in a PDF. And this is what I was kind of talking about, right? This is a complex page in a PDF, especially if you're doing a lot of financial stuff. You want to know your data, right? And you want to be able to perform RAG on it. Well, Llamaparse really helps make that better. And what they're saying, and what they're basically saying here is it's also really simple to use, which we'll go over in a second, right? You can import Llamaparse, and you have to do obtain an API key, but it's free right now. You can have the different result type and verbose, so you can see what's happening in the background. In order to make the next project work, you do need to get an API key, right? So if you go to llamaindex.ai, cloud.llamaindex.ai, I'll have this link in the description. I'm gonna have a bunch of stuff in the description, so it's all gonna be there. But this will be there, and once you log in or just create a login, again, this is free. You go over to API key on the left. Here are well, it's going to load all my API keys. I've already created a couple, but you'll just generate a new API key and enter a name here. It's sort of like OpenAI's way of doing it. And then you can go ahead and copy that, and we'll use that for the project. Okay, so let's go ahead and create a new file. And this is going to be the last project, right? We're in the last headway of this course. So O7, and just call it llamaparse.py. Now, you will have to pip install llamaparse before we go any further. So go ahead and do that now. So we're going to import nest underscore async IO. Then we're going to say nest underscore async IO dot apply. And then we say from llama parse, import llama parse. And then from llama index dot core, we're going to import again. I told you this is going to be, these two imports are going to be very common: simple directory reader and vector store index. And then we're going to say parser is equal to llama parse API underscore key. And then this is where you're going to put your API key. They'll say result underscore type is equal to markdown. And then I'm going to say verbose is equal to true. Now I'm going to go back and get my, I guess I have to get a new API key. So test course, copy this. I'm going to put this here. Of course, you could also use an environment variable for this, however you want to do it. But the next bit of code is a little different. So we're going to say file underscore extractor is equal to, and then we say dot PDF, and then we're going to say parser. We're going to say documents. The documents is equal to simple directory reader. Again, we're going to do dot slash PDF, and then the file extractor is equal to the file extractor. Here, I cannot spell right now. And then we want to load the data. Okay, moving down a little bit further, we are almost done. The next thing we need to create the vector store index. So index is equal to vector store index dot from documents, and then we want to give the documents. And then we can say query underscore engine is equal to index dot as query engine. And also you can persist this also into another different local storage, however you want to do that, but this is just an example of llama parse. And then we can just have a response. So we're going to say response is equal to query engine dot query, and then say who helped create this project. I'm just trying to think of one off the top of my head. And then we can go ahead and print response. Okay, so this is how you set up llamaparse. And then let's go ahead and bring this up here. I'm going to clear this and then right click llamaparse and run Python in file. Okay, and what it did here is it started parsing the file under a job ID. And then I guess this listed everybody that was a part of basically in the paper. Okay, and this is great, right? This is another way that we can have RAG retrieval. So what I am saying is that you should use llamaparse if you have more detailed or more complex PDF files. Give it a try and let me know how it's worked out for you. I just want to say, first off, thank you for completing this course. No matter how many projects you actually completed, just thank you for being here and being a part of this with me. And now you can build your own RAG pipeline to suit your needs, right? You can customize the data ingesters, you can customize how you want the system prompts, how you want it to respond with the LLM, how to create your agents, etc. There are so many options, it can be a little overwhelming and daunting with LlamaIndex. Well, if you like this course, I have 2 more right here with AutoGen and Crew AI. Thank you for watching, and I'll see you next video.